Cool. Hello everyone, welcome to one of the more advanced sessions of today, I think. So this session is both empowerment, but also a little bit of warning, right? So Neo4j user-defined procedures are a really sharp sword. You can be really, really effective with them, but you also can really well hack off your knee, basically, or your leg with them. So I want to kind of show you what you can do, but also want to caution when to build your own procedures versus when not, right? So that's kind of the scope what you want to look at. Okay, I have a bunch of slides, a little bit of code, a little bit Neo4j browser. I'll try to get through this interacting. If you have questions, you don't need to keep them to the end. Ask them immediately when you have the question, because I cover a lot of ground, and then at the end it would be too much stuff to catch up on things as such. Okay, why should I care about user-defined procedures? Isn't Cypher good enough? Right, so Cypher is a declarative query language, so that means whatever you write is not actually what the database does, right? What you write is taken by the query planner, the query rewriter, the query planner and execution engine, and it turned into something that's executed efficiently with the knowledge that the database has available. So it uses database statistics, information about selectivity of indexes and other things to decide how to execute these queries. But it's only so smart, right? So it's not like Skynet yet, so it can't tell you exactly, what's the single most efficient way of executing a query. The other aspect is also that the query planner compiles the query once based on the structure of the query. But if you input data sets, like your parameters of your query, lead to very varying volumes of data that you touch, then the query plans can sometimes be not optimal. So that's why there's a case for user-defined procedures from a performance perspective. So you sometimes have really tight SLAs, like 10 millisecond response times or things like that you want to be able to provide. And that's an efficiency question. The other question is encapsulation. Imagine you're building something for a project where you have quite complex business rules that you want to encapsulate into a query. If you write it in a Cypher query, it can become really long and convoluted, and sometimes you can't even express it because it, for instance, decides dynamically based on attributes of a node if it should go along this relationship or along that relationship, and then kind of the complexity of this query to write it. Either you have to do a lot of round trips between server and client to basically manually traverse. But in Cypher, it's not so easy possible to do these kind of dynamic, more imperative graph traversals as such. And kind of taking one of these kind of business logic rules and putting it into a named procedure also helps a lot of making it available for end users, right? So because then the end user has just a procedure with a name like, I don't know, compute impact of network outage of server X or something like that, right? So and then they pass in just the server name or the server ID that they want to compute it for, and then it does the work for them. So that's kind of the encapsulation aspect. The third one is integration, which means with user-defined procedures, you can actually do things like federated queries. So you can basically pull data from other systems while you're running your graph queries, and then either enrich your graph queries or when you return the results, or actually write data from the other systems to the graph in one go. So APOC has a bunch of procedures that do this. And the last one is portability, so you can basically take your code from single instance to cluster to DS and run it on all the systems, basically as such in a self-contained library that you can make available to lots of different people, and then they all have the same surface as such. Okay, hello world example for a user-defined procedure. This is actually a user-defined function. Just to set the stage is, you have a little bit of code here in Java, but you can use any JVM language. You annotate it with something like user function, and then you implement a little bit of code. So this should be readable for everyone, no even if you're not a Java developer. So basically, it takes an input parameter called text. If this is null or undefined, it returns null. And otherwise, it would return hello and the text and an exclamation mark, right? And so if I build this and put this into my server, and then do something like return example.hello and, for instance, graph connect, then it returns hello graph connect, right? So that's kind of my code that I wrote in Java, built, deployed to the server, and now it's available as user-defined function. So that's kind of the minimal hello world that you can do here. How does it actually work under the hood? Neo4j originated as an JVM library with a Java API under the hood. And this is still there, right? So while we expose Cypher and Bolt and drivers for all kinds of other languages, there's still the database running behind the scenes or under the hood has still these APIs available and has extension points that actually allow you to touch these APIs and have basically more effective bare metal access to the underlying operations of the database. So you basically use that API to the Neo4j execution engine, provide your extensions in the form of user-defined procedures or functions, and then they are available within your Cypher queries, right? So that's one of the benefits that we had with user-defined procedures since day one. To be honest, I also nagged one of the developers who was working on that in the last month before release to actually change the approach for user-defined procedures, which was really cool, to make them not just top-level entry points so that you can just run a procedure and nothing else, but to make them actually composable so they can be parts of the Cypher query itself, right? I know that it caused some downstream complexities in the Cypher code, so I apologize for that. But it really empowered everyone to have this kind of Lego block-like ability to take, it's like Unix philosophy, right? Lots of small tools that do one job, and then you use Cypher as the glue and as compose them together into a larger query, right? So you don't have to rewrite all the stuff time and again in every procedure, but you use Cypher for what it's great for matching patterns, for selecting data, for working with indexes, for bringing things together, and then the tiny bits that you can't do with Cypher, you just call out to the functional procedure to do it, and then you can compose them also within each other. And for me, also, user-defined procedures were a good way of learning for certain functionality that didn't exist in Cypher. Okay, if you can quickly write a procedure, we don't actually need to change the language, which means changing the parser, which means changing the planner, the execution engine, and everything else, just to test out if a certain feature actually makes sense. Is it useful? How can it be used? So for me, it was also kind of a learning means to see kind of, are people using this? Does it help them? How does it compose? And so on. And this is feeding back also into the Cypher team. And for instance, now the Cypher Surface team is working on taking certain aspects of APOC, not taking the code one-to-one, but taking the concepts and the ideas and the learnings and building them for real into Cypher, which is a great outcome. Yeah. Right. So there's already a number of built-in procedures into Neo4j that are provided by the database. And there's a command called show procedures that shows you all the procedures that are currently installed in the database. So if I run show procedures here, it actually returns 406 procedures in this gigantic list. You can also do things like show procedures, yield name, where name starts with, let's say, DB. And so I get only a subset of the procedures back. So I can actually use these show commands with a little bit of Cypher syntax to narrow down, for instance, things as such. So there's show procedures and there's also show functions, which shows then user-defined functions and aggregation functions. And so, for instance, we see that there are 260 APOC functions in this database. I'll talk about the difference between functions procedures in a second. So, and how to use a procedure, you just prepend it with call, procedure name, and then run parentheses, and then you're good to go. So that's basically really straightforward. But there's actually more happening behind the scenes.
Hey, Michael?
Yep.
Quick question. Is there an implicit return statement there? Because
Yes, that is kind of the top level call that I mentioned before. Okay. It's like actually a separate execution path in the planner which shortcuts lots of the Cypher planning thing, because it basically just does an call and then implicitly returns all the declared columns for the procedure. Sometimes there's a little bit more, so you can actually dynamically add, not really dynamically, but you can decide to return certain aspects of a result or not, depending on compute costs. And so this is kind of the minimal call as such. It's actually a good question, because I wanted to show you basically what's the minimal thing. And now my animation doesn't really work. Okay, so the minimal thing is kind of just call procedure. That's it. That's the number one. So then the next step is you can select certain fields to return from the procedure field, where you just spell out the fields that you want to be returned from the procedure. And then you can add conditionals, like here with a where clause. And then, because it's kind of composed in Cypher, then you can, for instance, call a second procedure with the results that are remaining after this where clause is applied, right? So, and then you just return the rest. So what this does actually, it lists the currently running queries in the system, filters all the ones out that have been running for longer than a second, and kills those queries, right? So that's something which you basically operationally, if you have runaway queries that are not captured by the transaction timeout, you could use this to clean up stuff that's been running for a while, and that's just one single statement. And here you see nicely the composability of user-defined procedures, right? So that's nice. So good. So for me, UDFs, user-defined procedures and functions, basically bridge the gap between low-level extensions of the database and the surface that you use from Cypher with a driver. So that's why I think I see them really like a bridge between the internals of the database or the Java APIs and what Cypher does. And so it allows you to extend database with new functionality. They're quite easy to use from a user perspective, and they're actually also not that hard to write if you know what you're doing, of course. But it's a really nice surface API for extending the database as such. So what is there? So I already mentioned user-defined procedures. They can read and write to the database. They are stateless, so they're not meant to accumulate state, because they will be called time and again, and if you accumulate some kind of state, then it will just add up. What's interesting about procedures, they can stream results. So if, for instance, if you have a generator that generates like an infinite amount of data, then you can have a procedure that actually does this, and then you use Cypher's means of like skip limit and things like that to just select a certain subset of this data. So it's also really nice if you consume data from another system and you get it in a streaming manner, you just pass along the stream of information to Cypher, and then it's not keeping this state anymore anywhere. It's like a hamster wheel basically passing through. And you can call them, as I showed before, either a standalone procedure call or embedded in a Cypher statement. Right. Next one is functions. Functions are like the lightweight cousins of procedures, because a function is called everywhere where you can have an expression. In Cypher, they are read-only, so they can't write to the database. Again, they're stateless, and they have a single result. While the procedure can produce a stream of results, a function has only one single result. But you can use them anywhere, right? So it's not, no matter if it's like a predicate, it can be something like that creates data, something that filters data. Everywhere where an expression is allowed, you can use a function as such. And then aggregation functions, which are a little bit of a different beast, because aggregation is usually stateful, so you have to accumulate things. So you can imagine if you do like a sum function, then it needs to sum up stuff, so it needs to keep the running total so far, right? So that's kind of the accumulating state. They're also read-only, aggregate results, and they can only be used in aggregation. So in with or in return clauses as such. So that's basically what's there in terms of possibilities. And when should I use them? So in general, I advocate to try to use as much plain Cypher as possible, because that's really properly planned by the planner and the execution engine. So there's the most optimization possibilities from the engine itself. But if you hit certain limits, either the performance limits or just functionality limits, then I would pick existing. First of all, I would pick existing procedures and functions, so I wouldn't start with writing my own from the get-go, but I would just first look what's already there, what can I use, and then I would use them as such and then go for that. Right? Mentioned already compactness and when something is missing in Cypher. How would you build one? So if you have very special needs in your business, so for instance, I was talking to some folks who do digital twins for telco networks, where there's a very specific way of how you navigate like the wires of a cable from one connection point to another one, which is really complex to express with a lot of rules. Where these business-specific needs, it's not possible to express them in Cypher. The other one is kind of if you have 10 milliseconds SLA and you can scrape off half of your runtime of your query, then that makes a big difference. Or if you have certain aspects that you can't express in Cypher from a data structure perspective. So for instance, if you have certain data structures like, let's say, a bit set or a tree data structure where you want to keep intermediate data to compute something, then these data structures don't exist in Cypher. Cypher has maps and lists, but you can only create them declaratively, not programmatically. So from that perspective, you need to use something else to use these kinds of data structures as well. Or if you have an integration that doesn't exist, for instance, in APOC, and you have to integrate with a certain system that you want to do via a procedure, then that's also a possibility to use them. If you compare Cypher with the Java API, Cypher, at least for me, it was always very focused on readability, making it easy to learn, making it a humane language as such. You start with a pattern and then everything circles around patterns. And that makes this kind of consistent concept of pattern in the center of everything, and the rest is just decoration of the pattern, either for creating data, for finding data, for manipulating data as well. It's declarative, so we benefit from the execution engine, and it's available through all the drivers and through all the surfaces. So no matter if I access Neo4j via Cypher shell or browser or the Kafka connector or Graph Data Science client or any other driver, I can always use Cypher for that, which is really nice. And we have the limited data and control structures that I mentioned. So I mentioned data structures, but for control structures, so for instance, doing arbitrary conditionals for execution flow control, or for instance recursion in Cypher, is possible in very limited circumstances, but not general. So it's not, from that perspective, not really Turing complete as such. So the Java API was the original API of Neo4j. It basically says I have node objects and relationship objects, and then I can set properties and get properties from nodes and relationships. I can get or navigate all relationships of a node and stuff like that. I can start transactions, stop transactions. It's an imperative API. And it's only available in database extensions, so you can't go into your client and say, I want to now use the Java API of Neo4j. You really need to be inside of the database. But the benefit is you have access to everything that Java provides, right? All the data structures, all the control structures, all the libraries, knock yourself out as such. Which also comes with the disadvantage that you can knock yourself out, and for instance, by pulling in a dependency which allocates either a ton of memory or pulls all the compute resources into your procedure, that means there's nothing left for the rest of your system. So that's obviously kind of the challenge, how to balance what you do in your procedure versus the needs of the rest of the system, right? So that's something that we, in the early days of graph algorithms, which is now GDS, had is, it's a massively parallel implementation. So when it has like 200 CPUs available, then it uses 200 CPUs, and then basically the rest of the database has no resources anymore. So we had to add basically means to limit concurrency, for instance, right? Or make it smarter about how much concurrency should actually be available to a single procedure as such. And so how would you go about building something like this? So you can pick any JVM language, so say Java, Kotlin, Scala, Groovy, or other languages as well. In general, I recommend to actually separate the procedure layer from the implementation. So it's basically similar to when you build, let's say, a REST API, that you actually want to separate the code that you put into something like a controller or a service from the underlying code that actually does the computation, which is has the nice benefit that you can test your implementation completely independent of the procedure surface. You can just instantiate the computation class that does whatever your procedure is meant to do in your unit test, run the computation. Sometimes, if it's a pure compute thing, you don't even need to start a database for the test as such, right? So because you have this isolation. But if you wouldn't separate this out, if you just implement all the code in your procedure interface, then you always have to go through the database infrastructure as such. Lesson learned from a painful experience myself, if you can, or actually you should avoid accessing internal APIs, right? So because they are not meant to be stable and not meant to be public. So if you grab any internal APIs, then they can change between even patch versions of the database, and then your procedures will break, right? So that's a drawback that you should definitely avoid. So only use the public APIs which are stable and meant to be used as such. So I already mentioned testing. So procedures can be easily unit tested the way how you would usually unit test your stuff in a JVM infrastructure. If you want to do integration tests, there's a really amazing test containers integration for Neo4j, which uses Docker to spin up instances where you can deploy your procedure jar to the container, run your integration test, and it shuts down the container or keeps it around for the runtime of your test as such. And yep.
What are the internal access to internal APIs? Those aren't documented, so or can you just get them by looking at the class?
So you can see them by looking at the class, by knowing that they are there, or by just using your API, your IDE to look at completion. Or Neo4j, as you know, is an open source database, so also the source code of Neo4j is available, so you basically can also look at the source of things, how it works as well. But really, don't do it. It's not worth it, right? So I can speak from experience. The integration test can also then use basically Bolt as the external way to interact with your procedures. So you're not just testing the internal surface, but you would really use in the integration test your procedure like an end user would use it through Bolt, through the driver, and then do things. Deploying procedures is actually the biggest pain point as such, to be honest, because you have to watch out that the version of Neo4j that you use to build your procedure matches the server that you deploy. So many of you have probably deployed the wrong version of APOC to a server version and then stuff broke, for instance. That's an example. So that's really important to watch out. You have to make it available in all instances, for instance, of your cluster, because cluster roles can change. And then suddenly, if your procedure is not available, it will just fail. And then you have to restart the server. That's also a big pain point. Usually you want to have the ability in a running system, especially if you have clusters with multi-database, you don't want to restart your server for deployment. So that's something that I would really love to see happening is procedure management in a way that you don't need to restart Neo4j, which is actually possible because Java class loaders can be garbage collected and replaced as well. Cool, so that's basically it. And so what are kind of some pros and cons of procedures? So I mentioned already some of the pros, like decomposability and encapsulation of functionality. You write them only once and you can reuse them just by having the name of the procedure. You can use all the Java features. You can test them properly with unit tests. You can refactor them. So if you can apply all the good software development principles, basically, because it's real code, basically, as such. And you can also apply control to procedures, which is interesting, because in Cypher you can express permissions to a certain level. But if you have certain aspects of work that a procedure does, then you can actually apply ACLs and rules or privileges, to procedures individually. You can exclude procedures from being loaded. You can select which procedures should be available. So you have fine-grained control of what do you want to make available to whom as such as well, which is really nice. So cons is you have to build them, you have to maintain it, you need to make sure that they still run, continue to run. You also need to upgrade, you have to adjust them if Neo4j APIs change, so you have to kind of follow the development there. The deployment aspect is a con for me, which makes it really hard. Also that you can't put them easily on Aura. So for instance, if it's not in the cloud infrastructure already available, then they are not there, right? So there's no way around it. And some of the other cons are actually from an execution and a planner perspective. So the planner can't look into your procedure, so it can't help you make it run faster, make it run better, or anything. For the planner, your procedure is a black box, more or less, right? You have some information, is this a read-write procedure and things like that can be used, but otherwise there's really limited things that the planner can do from that perspective, right? And the same is true for resource management. So every resource that you open or start in your procedure, you need to manage yourself as well. You need to make sure that you don't leak memory, that you don't leak file handles or threads or other things as well, which is also something that you have to be really careful about. Especially in procedures that stream data back. So while you're streaming back, everything is okay, but what happens, how do you actually notice that the stream is done and that you can now release resources and things like that. So, and you basically, you can't pass along feedback about internal operations. That's something that many people would love to see, is basically a procedure can't report back how many updates it has done to the database, or how many nodes have been created or relationships have been updated or things like that. So there's no API currently that the procedure can return this back. So when you run a procedure and the Cypher query says kind of 0 records updated or 0 nodes and relationships updated, the procedure could have still created 1 million nodes under the hood, right? So you don't know. And you need to know what you're doing, right? So I definitely don't recommend this to folks that are new to development or Java development. You should really know what you're doing. So 2 quick examples. Here, first for a function. So basically what you do, you put an add user function annotation on your method, like we've seen in the hello world. And all these methods become procedures. By default, it will use the method name and the package name of your class to determine the procedure name or the function name, but you can also pass your own name to it. They take name parameters, and the add name annotation can also, for each parameter, can also take a default value. So basically from right to left, you can omit parameters, because if they have default values, the runtime will substitute the default value into parameter. As I already mentioned, user-defined functions return a single value and are read-only. You can still get additional access to internal services of Neo4j by using an add context annotation on fields, which then injects you things like transaction, graph database service, and other things, logs, and so on. And all user-defined functions run within the transaction of the executing query. So if you have a query that runs, then every function that's called is running the same scope of the transaction of this query. So what would this look like? This is a function that takes a bunch of strings and delimiter and joins them together into a result string, right? So basically here I have my here I have my user function annotation. I can add a description annotation as well, which then shows up in show procedures as a help text, which is quite nice. Then I have my method, which has a single return type. In this case, it's string. Name is join. So because I didn't provide a name in user function, it's basically the package name, which is example in our case, and join, so example.join. It takes a list of strings and a delimiter where the default value is a comma. So if I don't provide a delimiter, it will actually default to comma. And then basically the implementation is super simple, because Java, since Java 8 or 9, has a join function on string, which takes a delimiter and a bunch of strings and does all the work. So actually a lot of the user functions in Epoch are just 1 to 5 lines of code as such, right? So because they just expose either a Neo4j or a Java feature to Cypher as such, that's currently not available as such. And then what you do is you build your jar, basically, and then see how this gets deployed. So if I look at my code here, this is my join function. It's in the package example. So it basically would be example.join, what comes out of this, and then I can use it here. If I look at how I would test this, I basically have some infrastructure help from Neo4j. There's an in-process Neo4j that I can build for unit testing. So I built this once before all my tests run, and after my tests run, I close this down. And what I get from this in-process Neo4j, I actually can get a Bolt UI from it. And then I just connect to this in-process server with Bolt, run my Cypher statement, and then basically do asserts on my results so that it's actually what I expect here. Right? So that's basically like a unit test. If I actually wanted to separate out what I actually said before, so this would actually be not a procedure call, but because this is basically just a single Java function that I expose, which has already been tested in the JDK kit at TCK, I don't need to test string.join again because that's something that actually should be working. Right? So then I built this, and how the building works is basically there is there's a shade plugin in Maven, for instance. So in my Java build script, there's a plugin which basically takes my code and any dependencies that I use and puts it into a single file, a jar file, and then I take this jar file, put it into my Neo4j server, and run it from there. Right. So that means, let's see, if I look at my terminal here, if I do Maven package, for instance, then it will run the tests, build it, and then the result is the jar that I then can take input into my Neo4j instance. So these tests take longer than I would like because it basically spins up a Neo4j server internally. So for the time being, I just skip them. Just to show you that it basically builds this jar. That's this one here. And I can take this jar now and put it into my server. So if I look in my plugins directory in my server, I see here both my jar that I built and epoch being in there, so that when my server starts, it loads the procedures from those two jar files and makes them available. So that means if I go to my server again, I can just call this function now, return example.join, pass my list of strings. For instance, I can say GCP Iowa region sucks, right? And pass in a delimiter because they didn't like me this morning. And then it creates this string for me. And of course, because it's a function, I can now, for instance, also say, I can just create a node here that takes this text as a parameter, for instance, also, right? So that's wherever I can use an expression, I can use this now as such. Cool. So we looked at the test code and the deployment. One thing is, if you have procedure libraries that use internal APIs like APOC and GraphTail Science, then you have to enable them in the Neo4j config and add them to the unrestricted security line, because otherwise they would not be loaded and executed in Neo4j for safety reasons. And then restart the server and then they're available as such. Cool. One reason why procedures or functions are sometimes not loaded are missing dependencies. So that's a good way to check in the debug log if the server complains about anything that's missing, tries to load something and it's missing, then you usually see that you forgot to add a dependency to your code base. For procedures, it's very similar. The main differences are that procedures can read and write to the database, and that they return the stream of data to the client. And this stream of data is actually value objects, so you have objects with public fields, and they are used as DTOs, and you return them to the client. And here's an example for this. So we have a procedure that exposes the internal Dijkstra implementation of Neo4j. Again, add procedure annotation on my method. And then the difference that it doesn't return a single result, but a stream of results. So the stream is an Java util stream. It takes a bunch of parameters again. And then the implementation is basically just getting from the internal Neo4j APIs the Dijkstra method. I use this relationship type and this cost property that I've got just passed in from the outside. And then I use this algorithm to find all paths from between the start and end node. I get a certain data structure back and iterable, and then I just use some minimal Java API to turn this iterable into a stream and actually create instances of my weighted page path result here for that. So basically turning what I get from Neo4j as an also kind of streamed version of data into a stream for the procedure as such. Cool. Any questions around this? Otherwise, I'll...
One question
yeah.
for you. Are there any APOC procedures that are good candidates to be turned into user-defined procedures by tweaking them, by adding some more?
I mean, all the APOC procedures are user-defined procedures as such, right? And so sometimes people also mix up APOC and user-defined procedures. So APOC is just one library that provides user-defined procedures. And all the APOC procedures are actually user-defined procedures. So if you look at the at APOC itself, so for instance, imagine we want to here, where's my Dijkstra? Sorry, it's pass. Is it pass? This one? Sorry, I forgot where I put the Dijkstra because I wrote it like 6 years ago or something like that. Expanders or something like that.
Expand that thing? Oh, path expander.
Yeah. Anyway, let's take something else. Let's take, what is another good one? Yeah, JDBC, for instance, load JDBC. So this is a user-defined procedure in APOC, basically which reaches out to a relational database and loads the data from a relational database. So you see exactly like I showed, it's also just a procedure with parameters and so on, and then it executes the SQL query and returns the result as a stream to Neo4j back. So that means when you want to modify an APOC procedure, you either take the code from APOC and put it into your own library, but it's actually better to open a GitHub issue and discuss what you want to have added or changed, and then it's easier to have a discussion around it. But otherwise, APOC is an open source library. You can pick code from that and modify it if you want to do it. So it's basically not different from your own procedures, just that they are basically being built and developed by a community of folks as such, and being actually transitioned now to engineering. At least APOC core is being transitioned to engineering as such, which is great. Yep.
There's oftentimes people that say there's a performance benefit for a procedure that's doing Cypher. How do you identify a problem with this?
Sorry?
Where the performance benefit would be such that it's worth writing?
Oh yeah, that's actually a really good question, because procedures also don't come for free, right? So because they have to be also instantiated and executed by the runtime. There have been parameters converted and passed into the procedure. Results have to be converted back to a Cypher's internal type system. So every procedure call also comes with a cost as such. And what I would do as such is basically measure the benefit, right? So what I would say is, okay, if my Cypher query that I write just in Cypher exceeds my SLA by X, and I don't see any optimization potential. By the way, if you want to learn more about Cypher optimizations, besides the course on Monday, there's also a Graph Academy course about Cypher tuning, which is really good. So I can totally recommend that. And it gets your Cypher queries should be much faster, or you can come to my talk tomorrow as well. So that's the other one. And otherwise, I would just measure it. Basically, I would run the procedure without an implementation. So I see kind of what is the cost of just executing the procedure. And you can actually generate some fake data so that you have the same cardinality of result conversion that's necessary. So you get an impression of, okay, what's the impact of the call cost as such. And then if your implementation, which you can also test separately, let's say is only a tenth or so of the pure Cypher runtime, and the execution cost only adds like 10% or something like that, then you're still 9 times faster than the original query, and then it's worth it. But it always depends on your SLA, right? So it's also kind of pointless to chase performance for performance sake. If you already make your whatever 30 milliseconds or 100 millisecond SLA, then it's kind of pointless to actually go down and get down to, I don't know, 50 milliseconds if there's no need from an SLA perspective, because it also comes with the costs of creating the code, maintaining it, and deploying it, and all the other things, right? So all the non-functional costs or opportunity costs you also have to take into account as well. Right.
Related to that question.
Sure.
Are there any out-of-the-box monitoring capabilities for Neo4j to just monitor my custom user-defined procedure?
Not really, because Neo4j actually sits also kind of one layer above the JVM as such. So Neo4j is running on JVM also as an application, to say so, right? So what you would do is rather use the typical Java profiling tools to look at things like that. So you can use something like async profiler or JVisual VM to look at what your procedure is doing. Usually you know when it's misbehaving, right? So if it's kind of not completing within a certain time frame or allocating too much memory, and then these general Java profiling tools are working really well with procedures as well. So we just had for instance, I had a colleague this week who had also written a procedure, and he said, I think I know where it spends its time, and I just want to check. And then he came back and said, okay, after I ran like a async profiler and looked at some flame graphs, it was really surprising for me where it actually spent its time, and it was not where I expected it to happen. So usually it's better to measure and validate than just follow your own assumption, because otherwise you can try to optimize something where actually the time is not spent, and then you're not optimizing the actual bottleneck. So I also recommend always measure, optimize like the biggest bottleneck, and then measure again to see perhaps your fix actually created another bottleneck somewhere else that didn't exist before, because, for instance, throughput was limited because of the first thing that happened, as that, right? So always like do one step at a time, then remeasure, look at, am I now below the SLA, and is there a new bottleneck that I need to address as such, right? But I can really root for async profiler, and for instance in IntelliJ it's also integrated, so you can just connect to a running instance and get nice looking flame graphs from that as well. Cool, any other question? Yeah.
Is there any plan to create a Graph Academy course for building stored procedures?
As I said, it's a really sharp sword, and I'm not sure in how much you want to encourage people to start writing their own, right? So, I mean, in some way, I'd rather have people provide feedback to Neo4j's engineering team to say, okay, so let's put it that way. If it's about like missing features in Cypher or things that you can't express in Cypher or in GDS, then I would recommend going the route of providing feedback to the engineering team of Neo4j. If it's about these, what I mentioned in the beginning, these kind of very complex business rules and traversals and things like that, then it actually makes sense to do that, to build a user-defined procedure for those. So I'm kind of torn. In the old days, I wanted to create a course around it, but for once I haven't gotten around to do it. And the other thing that's also, especially today, more difficult is if you're going to use Aura, you can't deploy your procedures as well. So that's another issue that we need to address as well, right? So from that perspective, I think it's more exceptional cases where you need to build your own, and it's better to actually contribute to things that are existing. So for instance, one interesting example there is for these kind of more complex traversals, what you did in APOC is actually we used the internal traversal API of Neo4j inside of epoch procedures, but then expose like a configuration to the outside world, so that you don't get 100% coverage of all the things that you could do with the internal traversal API, but you get at least to, let's say, 70-ish% of all the use cases that you would do. And then the only thing that's remaining is if you have really very dynamic, conditional, that have to be computed at runtime when you decide where to go. And so that's actually a nice way where you actually can express these kind of things with parameters to a procedure as such, right? What I would love to have is also the ability to actually pass Cypher, structured Cypher to procedures. Because then for once you wouldn't have to pass strings, Cypher strings to procedures. And you could also pass expressions. So for instance, imagine you had then the means to pass a Cypher expression to a procedure as a parameter. Then within the procedure you can just apply this expression and it would be executed in context. And then you could even kind of do these kind of dynamic things, because then you would actually pass a computation callback to say so to the procedure, and then internally the procedure would just do computation.apply and pass it in parameters, and then you would know if I have to go left or right or something like that. And also from a parser checking perspective, it would be really good if you can avoid to pass strings in procedures, because for instance what we did in epoch, just as an safekeeping measure, is when you have these procedures where you pass in Cypher fragments, we actually run an explain up front before we actually call the procedure, so that when the Cypher parser or planner brings an error, then it errors really early, not after basically the engine is already running and doing stuff. So that's something that we did, but it would be nicer just to lift this out into like Cypher land and not have it inside of the procedure as such. Cool. Actually don't know how much time left we have, but let's see. I lost track a little bit. Okay. The real world example is a more complex example. So what we can do is, here our task is, we have a set of categories. So imagine you have a data set like, I don't know, like movies or items or questions on Stack Overflow which have tags. And you have a set of tags and you want to find all the nodes in your graph that have at least an overlap of this set of tags, right? So you pass in 4 different tags to a Stack Overflow data set, and it would basically provide all the nodes that kind of have these 4 tags, right? So you can write a Cypher statement for this, like this one, which takes like 2 million dB hits to run, because it basically executes first the lookup and then an aggregation, allocates quite a lot of memory, and then basically returns the results based on what's the size or what's the equivalence between the text that a question has and then Stack Overflow and the passed in tag name thing here. So that's quite involved. And better solution is actually this one, which takes your tags, determines which of the tags has the lowest degree, so which is most selective basically, and then you get the questions for this tag. So you only have a small set of questions, and then you check these questions against the other remaining tags. And because they're already sorted in ascending order of degree, the next tag has also just few questions, comparatively at least, and so it filters out already stuff that doesn't even pass to the, imagine Python is a tag that has a lot of questions on Stack Overflow, right? So most of the questions don't actually make it beyond Neo4j, because there are only like 21,000 questions on Neo4j on Stack Overflow. So when Python has probably like 500,000 or so, right? And so that's kind of the sorting by degree, and then starting with a driver as the head and doing the tail thing. So optimizes it from 2 million dB hits to 90,000 dB hits. And then there's some other optimizations that you can do. It goes a little bit down. But okay, but if your SLA is so low that even if this query touches a large part of the graph, but you still want to be faster, then you basically can say, okay, now I've optimized the Cypher query as much as I could. What else can I do? And then you could say, okay, perhaps this is a time when I need to write a user-defined procedure as such. And so how would you do this? So we pass in the list of aggregation. We pass in the list of, this should say tag names. Yeah, that's what was confusing a little bit. pass in the list of tag names. We want to find a tag with the least questions, like the sorting by degree. Put all the other tags into a set, and then iterate over this minimal tag and for each question, and then just check against the set. Okay, is this basically tag of this question in the set? Yes, no. So you do not a list comparison, but you do a set existence check. That's kind of something that I mentioned in the beginning. If you can use data structures that are better suited to what you want to do, you have more efficient complexity, basically, of your execution. And so the implementation looks like this. This is my procedure class. Basically, that gets, actually, this is now a transaction. Actually, I can show it to you in the code. That's probably better. So that's called shared tags. This one here. So we get a transaction injected, lock, then we have our tagged and tagged relationship type, the tag label. And this is our result class. Oops, this does not, why doesn't it not show? I think PowerPoint stole my screen. Or somehow my screen switched. That's actually really interesting. It seems to change the screen mirror setting when you run PowerPoint. That's not really nice. Okay, now we're back to mirroring. Sorry for that. So this is our transaction that we pass in, our log, relationship type, and labels. And this is our result column, right? So we basically have a class that has a title, tag, and weight. And this is what we return as a stream from our procedure. And so our procedure call will have a title column and weight, and then a tag column that I can use. And then this is my procedure. And then the implementation is pretty long and dense. But what it does is basically it gets our goes over our tag names, finds each of the nodes with these tags from the index, and then basically gets the degree of each tag and puts it into a list. And then it sorts this list ascending by degree. So I have then a list of basically node, comma, degree, so number of questions in my list. And then I can take the first element of the list as my driver and the rest of the list to check against. So this is my first node in the list. And then I basically get all the questions of this node, of this tag node, put them into a set. And then I also put, for all the questions, I put their tags into a set and check them against my tag names. And when it's in there, then I can basically, then the questions that remain are the ones that have the same tag count as such. So, and then I take my results. So these are the questions that actually fit the condition. And then I basically just take each entry and turn it into an instance of my class that I want to return here and stream this result back. So you see, if you compare this code with the Cypher code, it's way more complex, way more involved. So the cost of writing this procedure is not just basically that I have to take into account how much I save, but also how much opportunity cost is here, right? So because this is code I have to maintain, understand, and continue to support, and that's why the question is, okay, is it actually worth it doing this? And this is an example where the Cypher query is actually not too bad. And with the procedure, I actually wonder if I had the result value. No. So the procedure can shave off another, I think, 20,000 dB hits or something like that. So it's not like a massive gain, but it kind of gets you to a certain stage. The other thing is, when you write a Cypher statement, then you also participate from all the improvements in the Cypher runtime. So if I look, for instance, at parallel Cypher runtime, at more bytecode compilation for Cypher and so on. So then I actually, without actually changing my query, it gets faster and faster with each Neo4j version. With the new storage abstraction that's coming on, all the other improvements. So actually, I really need to think about, is it worth it for me to kind of, from a pure performance perspective, to do this, or is it not worth it? And oftentimes, while it seems intriguing at the beginning, kind of the opportunity cost is just too high to do it, and then I'm actually good doing it in Cypher as such. Okay, and to close, I quickly wanted to go over a bunch of procedural libraries and procedures that exist, and I hope that PowerPoint doesn't kill my thing again. I probably did. So we have built-in procedures in Neo4j. I already showed a bunch of them. So many of them are now actually moving to admin commands like show commands and so on. I'm not a big fan of admin commands. I always hated them in relational databases, and I don't like them in Neo4j either because I can't ever remember what the syntax is. I always need to look them up, and then they are not composable, right? So while Cypher and procedures and user-defined functions are composable, so when I have the stuff in there, I can compose them and then use the outputs of these commands to do more. These show commands have a limited set of Cypher operations that they support, and they are not composable. That's really my biggest pet peeve, besides kind of remembering all the syntaxes. So we have index constraint, schema visualization, cluster management, which is more for internal usage. The security procedures have been already phased out. There's some database state things. Showing procedures and functions, as you saw at the beginning, are also phased out. And there's also query transaction management. So like list queries, kill queries also turned into show commands, and some configuration management. So actually, I think in the midterm, despite my attempts to avoid this, we'll lose most of the built-in procedures in Cypher in Neo4j. But so be it. But fortunately, we get APOC into Neo4j, so we get a lot of built-in procedures back. So,
Hey, Michael,
yep.
What does phase out mean?
They are turned into admin commands like show commands and exactly. Yeah. Cool. Then we have APOC. My baby that I started to write in 2016, and where now a lot of people have contributed a lot of things, and it does a ton of stuff. So it's kind of the Swiss Army knife of things. Sometimes I'm wondering if I kind of created a monster, also like a Frankensteinian monster in some way, because it does too much. And for some of the stuff, you could actually have argued that it would have been better to move it to the client and do things from the client side. But it was also a lot of fun to build all this stuff as well. So, but there are lots of good things, like for instance, map and list functions that are in APOC are super useful. The temporal functions for parsing or formatting date and time into things. So these are all things where I think that they will go into the proper Cypher language, and then everyone benefits from them for real as such. But there are also some operational things and federation, NLP procedures, and so on. Right, so there's a lot of interesting things in APOC. And then the graph data science library that we've seen and heard so much about is also built on top of procedures. So it uses procedures as its surface, and then under the hood it does a lot of internal, very high performance in-memory Java execution as such. So from that perspective, every piece of functionality in GDS is currently exposed as procedures. I don't know if that will change, if it will also change to a kind of more like a Cypher or command syntax, but that's currently the state here as well. There's Neo-semantics, where I didn't get a nice picture from Jesus, which integrates with RDF data sources. So you can load RDF data, you can do a little bit of inference, you can project Neo4j property graphs as RDF resources and things like that, which is really useful. And so these are a few examples of existing procedural libraries. What I want to say is, as I said before, if there's an existing procedure out there that already does what you want to do, or almost does what you want to do, rather work with the procedure library maintainers and authors to help you make it work for you, then kind of build your own. That's one of the things I want to get along. So if you really want to build things, there are documentation in the Java reference of Neo4j how to write procedures. There's this example repository that I showed you a bunch of examples from that's on GitHub that you can use as a starting point. There's also a developer guide, and you can read the source, for instance, of APOC Neosemantics or Graph Data Science to learn more from hands-on examples. So we covered almost all the questions. Does anyone have remaining questions? Yes.